section we'll be talking about motion in space. So first of all, let's recall from Calc 1 what we know about position, velocity, speed, and acceleration. Well, if our position was s of t, then our velocity v of t was the derivative of s of t. The speed was the length of the velocity, and the acceleration was a of t was either the derivative of the velocity or the second derivative of the position. The same thing is true with vector valued functions. So if r of t equals x of t, y of t, z of t for t greater than or equal to 0 is the position of an object moving in three-dimensional space, then the velocity of the object is given by r prime of t, and the speed of the object is given by the magnitude of the velocity, and the acceleration of the object is given by the derivative of the velocity or the second derivative of the position. So let's go ahead and try one. We have r of t equals 4 sine of t, 4 cosine of t, for t between 0 and 2 pi. So if we graph the trajectory of the object, we see that it is making a circle with radius 4. And we will go from 0 all the way around to 2 pi. And notice that our trajectory did have a direction. We were moving this way along our circle. So now we need to find the velocity and speed. So the velocity is r prime of t, so the derivative of 4 sine of t is 4 cosine t. The derivative of 4 cosine of t is negative 4 sine of t. The speed of the object is the length of r prime of t, so that is the square root of 4 cosine t plus negative 4 sine of t squared, which is the square root of 16 cosine squared t plus 16 sine squared t, which is the square root of 16 times cosine squared t plus sine squared t, which is 4, and cosine squared plus sine squared is 1, so that just gives us 4. So the speed is 4. Acceleration is the second derivative of r, so that gives us negative 4 sine of t and negative 4 cosine of t. Finally, we're asked to sketch the position, velocity, and acceleration vectors for t equals 0, pi over 2, pi, and 3 pi over 2. So we'll do position in red. So at 0, sine of t is 0, and cosine of t is 4, so the vector 0, 4. At pi over 2, we have the vector 4, 0. At pi, we have the vector negative 4, 0. And at 3 pi over 2, we have the vector 0, negative 4. Then we are going to do our velocity in blue. So we have the vector 4, 0, 4, 0. We have the vector negative 4, 0, the vector 0, negative 4, and the vector 4, 0. And since those are derivatives, and they are tangent to the trajectory, and they have length 4. And then finally our acceleration, we'll do in green. And that is negative 4t, negative cosine t. So that's 0, negative 4. Next we have 0, negative 4, negative 4, 0, and we have 0, 4. Let's have you try to find the velocity and speed of the object and the acceleration of the object when r of t equals 2t, 6t cubed, 1 plus t for t greater than or equal to 0. So pause, and when you're ready, come back. So to find the velocity, we're going to find r prime of t. That is going to be 2 18t squared 1. To find the speed, we find the length of r of t. Well, find the length of r prime of t. So that is 2 square root of 2 squared plus quantity 18t squared squared plus 1 squared, which is the square root of 4 plus 18 squared plus 324 t to the 4th plus 1. So that is square root of 5 plus 324 t cubed, and we'll leave it looking like that. Next, we're going to find the acceleration, which is the second derivative of r. So that would be the derivative of this. So we get 0, 36t, and 0 for our acceleration. So let's say we have two different position vectors. One is r1 is the position is given by the vector 4 cosine of t, 4 sine of t, and the position vector r2 of t is given by 4 cosine of 2t, 4 sine of 2t. So we are going to see r1 in black and r2 in pink. And we notice that they are traveling along the same trajectory, but object B is moving faster than object A. Next, let's find the velocities of these objects. So r1 prime is, we found this before, it was 4 sine of t, negative 4 sine of t, 4 cosine of t. R2 prime of t is 8, negative 8 sine of t, 8 cosine of t. And if we found the speed of these, well, we would find the speed of r1. We found that before to be 4, and if we found the speed of r2, which you can check these on your own, is going to give us 8.